All right, so we went through this part, and we got as far as we went through all the rules where everybody was comfortable with the rules. Logs are exponents, so think of your exponent rules. When you multiply like bases, you add the exponents. Oops, sorry. So when you have a product to multiply, separate it into a plus, an addition. When you have a quotient, when we divide like bases, we subtract the exponents, separate it into a subtraction. ln and logs work the same way. Power rule, when this is by itself, there can be nothing in front of these guys, then you can bring the power down. And the last one is your root rule. Make sure you get that radical out of there and make it a fractional exponent and then bring it down. So let's take a look at these. You can expand and contract these. So when you expand this, what am I doing between all of these? Multiplying. So when I multiply like bases, what do I do to the exponents? Add them. So this is going to separate into an add. Keep the same base. You don't need to say base 10. I put it there because this is where the base would be, but you don't need to say base 10. So this is log 5 plus the log of x cubed plus the log of what? And what else do you see we could do? You could bring the 3 down. Use your power rule and bring the 3 down. All of these bases will always be the same when you expand it. You expand it off of this one. This is probably where you had in Algebra 2. A lot of times they'll say, set the log of y equal to m, set the log of x equal to m, and then you had to like separate them out, just replace them. That's probably what you saw then. Now logs and ln's work the same way. If you want to undo, the last thing that you would have done is the first thing you want to undo. So if I was to solve this and put an x in here, multiply it, subtract, take the square root, the last thing I did is divide. So that's the first thing you want to undo. So when you're dividing exponents, what are you doing? When you're dividing like bases, what are you doing to the exponents? Subtracting them. So this becomes a subtract. Okay. Now, get this radical out of here. What do I raise this to? What power? To what? 1/2. Good. There's a 2 index in here, which we don't write. And all of this is raised to the 1 power. So 1/2. And then bring this down. Power rule. Leave this be. This is your argument right here. Don't change that. You have nothing to separate that with. And it doesn't work like a distributive. ln 3x minus ln 5. Doesn't work like that. We kind of did one of those yesterday. We saw that it didn't work that way. Good? Everybody remember doing these? Yeah. Do you kind of remember these? I think Algebra 2 kind of spent a lot of time with this. And then the opposite of this is just condensing them. Okay, so now the first thing you want to do is get rid of these things in front. Bring these up first. If you want, put this back to a radical. In the end, I need the radicals, not the fractional exponents. So this was the square root of x. Okay, and now I need to condense this. I've got 2 logs with an add. I need to condense this into one, God bless you, into 1 log. So think a minute. When you were adding exponents, what were you doing to the bases? Multiplying. So this guy becomes the product. One log statement. It's got to come down to 1 log. 1 term. Yes. this looks a little strange. I don't know if you want to put it like this. If you want to put a whole bracket, you can.
Should we bring down the 3, 2, and make it easier?
For x plus 1, cubed.
No, I mean, like, a little index and a... Never mind.
This guy?
Never mind.
You're okay? Okay. Sometimes they look a little strange, but all we're doing is expanding and condensing. I think the major goal is to see where are these coming from. And you want to get rid of these before you condense. You can't condense this with these coefficients out here. So those, you have to get rid of those. Okay, and the last one, what would I do here? What's the first thing I have to do? Bring the 2 up. I got to get rid of that 2. And when I was subtracting exponents, what was I doing to those bases? Dividing them. So this comes into one term, and it just becomes a divide. Okay? Not so bad, right? Okay.